Today we'll discuss about JEE Men's 2016 paper Physics. Hello students, let us solve question number 7. So question is, a pendulum clock loses 12 seconds a day if the temperature is 40 degrees centigrade. That means if the temperature is increasing, there is a loss of 12 seconds in a day, and gains 4 seconds a day if the temperature is 20 degrees centigrade. That means you decrease the temperature from a given temperature, then it gains time, and if the temperature is more than the correct time, then correct temperature, then it loses the seconds. The temperature at which the clock will show correct time. So there must be a temperature at which the clock is showing correct time, and that is, if the temperature is above this, then it loses 12 seconds, and if it is below that, it gains 4 seconds a day. Corresponding to those the temperatures are given when it is losing or gaining, and the coefficient of linear expansion of the metal of the pendulum shaft. The shaft means the bar which is hanging and swinging like this. This is the pendulum bar. Are respectively. So you have to find the temperature at which you get the correct time, the temperature you have to find, and the alpha value. You can see that the alpha is everywhere same. Mostly the number 1.85 is same. So the thing is that we don't have to calculate for alpha, but then we will calculate alpha. Once you get theta, then there is no common theta like this. Suppose the answer is 25, then this is the answer. Is 30, this is the answer, because there is no other 30 degrees centigrade. So once you find this, that will be the answer, but we will find both. So to do that, first of all, we have a relation in case of a pendulum. Even if it is a bar pendulum, it swings like that, and the time period of oscillation of this pendulum is 2 pi L by G. This formula you can use. Now, if I differentiate this equation with respect to L, then I will get dt by dl equals to, this is a constant, so I will just that will come out, and that will give me, I will just write this out, 2 pi under root of g will come out, and the derivative of L s to power half is L s to power half is half, and then L s to half minus 1. Okay, this then this is minus half, that is come down, so that gives you 2 pi under root of g 1 divided by, this is minus half come down, so 2 root of L. So dt over dl equals to this. So if I take d from here and this from here, and I can write that dt from here, I can write dt as 2 pi under root of g 1 upon 2 root L into dl. This equation, if I divide here, if I divide this equation and this equation, suppose this is 1 and this is 2, what I will get? Dividing equation 2 by 1, basically I am just going to derive the equation that we are going to use, the formula that we are going to use for that calculation of the time. Now dt over t of this side, and that side will be 2 pi, first I will write that under root of g 1 by 2 root L delta L. Okay, so this one is there, divided by 2 pi under root of L by under root of G. So you can see that this 2 pi will cancel out, this will cancel out, and this will becomes 1 by 2 dl over L. This is the formula I'm going to use. That because t is proportional to under root L, I could have directly write that I could have written directly delta t by t equals to half delta L by L. From here, this is the equation we are going to use to find this. Now, what is this delta t? That is loss or gain of the time in seconds, and this is the time of 1 day, duration of a day. This is the change in length of an original length. Again, we have to express this delta L upon L as a function of alpha and the change in temperature. We know that from coefficient of linear expansion, the formula for coefficient of linear expansion is given by alpha equals to change in length upon original length and change in temperature. So from here I will write delta L over L. From here you can see here that is equal to alpha delta theta. This I will substitute here, delta L over L, delta L over L. Here I will substitute alpha delta theta. So the equation becomes dt over t equals to half alpha delta theta. This is the equation that I am going to use to solve this problem. Now, how to solve this problem? First of all, what is given is that at a temperature of 40 degrees centigrade, and the question is given at 40 degrees centigrade, it loses time, and at certain correct time, suppose theta is the correct temperature at which the pendulum gives correct time. This is the correct time, and at 20 degrees centigrade it gains time. That means in between this 40 degrees centigrade and 20 degrees centigrade there must lie a temperature where the clock gives correct time. If the clock gives correct time at a temperature in between the two, how to find that? So from here, if we deviate from this to 40 degrees centigrade, then the difference here is this minus this is the deviation, and from here this is the deviation. So during this deviation, that means 40 degree minus theta, this is 40 minus theta is the delta theta. This is 1 delta theta, and this is theta minus 20 is another delta theta. During this delta theta, it loses how much seconds? 12 seconds a day, and during this delta, it gains 4 seconds a day. Okay, so this is the theta at which it gives correct time. So we have two situations. So we have to apply this formula twice. One for this delta here, and another for this delta variation here. So we will have two equations, then we will solve it. First of all, this delta t is this one. This one is your delta t or dt, whatever they say. This is also another delta t. So I'll use this equation for this part of the question, that is when the temperature is 40 degrees centigrade increasing to 40 degrees centigrade, then this is delta t becomes 12 divided by this t. I'll keep it as t for the time being. I'll put it at later instant. T equals to time in 1 day. So this equals to half of alpha. Delta theta is 40 minus theta. Theta is the temperature at which it gives the correct time. Similarly, I'll use for this one, this is 4, so this is 4 divided by t equals to half of alpha theta minus 20. Why it is theta minus 20? Because this temperature is greater than this temperature, so the difference I have write it. Okay, so if I divide these two equations, what I will get? If I divide these two equations, what I will get? So dividing these two equations, this t will cancel out. 12 by 4, it is 3. This half, alpha and alpha will cancel out. Here it will be 40 minus theta divided theta minus 20. So theta minus 20. Now, if I cross multiply, because this is one equation and one unknown, I can get the value of theta by cross multiplication. If I multiply this with this, I'll get theta 3 into theta minus 20 equals to 40 minus theta. This implies that 3 theta minus 60 equals to 40 minus theta. From here, I'll get 1 theta will come to this side, this becomes 4 theta. 4 theta equals to this 60 goes to that side, when adding with 40 it becomes 100. So theta comes out to be 25 degrees centigrade. So what is that theta? Theta corresponding to the temperature when the clock gives the correct time. So at 25 degrees centigrade, the clock gives correct time. If the temperature increases to 40 degrees centigrade, the length increases. If the length increases, the time period will increase. Time period will increase means the pendulum will go slow, the clock will lose time by 12 seconds in a day. Similarly, if the temperature is brought down to 20 because of loss in temperature, the length of the bar decreases. When the length decreases, the time period will also decrease. That means the clock moves faster. Because of the clock move faster, it gains time in a day. That in a day it gains 4 seconds. So this is the temperature when it gives the correct time. So in the question, we are asked to find the temperature at which the clock gives correct time. That temperature we found as theta, which is 25 degrees centigrade. So if this is the answer, then I will just advise you not to go to find that alpha value, because once you get this will be the answer. But then we have to find alpha. In case there is another option, suppose 25 degrees centigrade here, then you have to find alpha. Okay, but in this particular situation, you don't have to find alpha, because this is one of the this first one you got, and the second one obviously has to be this, because there is no other choice. But still, we will find alpha. So let us find alpha. How to find alpha? Then you can use either this equation or this equation. In both these two equations we got alpha, so we'll take alpha, rearrange, put the value theta, and get a t. Also you know it is about time in one day, which whatever is the value we'll put it and get it out. So rather I will use this equation, because this number is smaller number, so I don't have to multiply with a bigger number. So 4 upon t equals to half of alpha theta minus 20. This equation I will use. Already I've got theta as 25 degrees centigrade, so I'll put theta as 25 over here. Then this will become half alpha 25 minus 20, and this is 4 divided by t. Now what is alpha? This 8 will come to here, 2 and 4 becomes 8, so alpha becomes 8 divided by t into this 25 minus 20, this is 5. So 8 by 5 into t. Now what is t? That will substitute and see what we are getting. The value of t is the time in one day. That we have to write in seconds. In a day, in seconds. So I write in one day there are 24 hours. 60 minutes, 60 seconds. So if I substitute that here, I'll get 8 divided by 5 into 24 into 60 into 60. If I solve this, then probably I will get that. So let us solve that. I'll just because I've got already the initial values everywhere it is the same, that is 1.85 and 10 raised to 7. So I have to check this order. So the number must be 1.85. So I don't have to calculate for that because it's given. So I'll write this 60. This is 24. 8 3s are 24. So this is 5. This is 60. The 300. 3600. So I'll write 1 divided by 3 into 5 into 3600. Now if I this is 15, so 15 I have to multiply with this, so this becomes 3600 into 15. I just multiply, so rather I will multiply 36 with 15. This becomes 0 6 5 15 6 are 90, 0 9 carries, 45 9. 45 9 is 54. So 54. So this is 1 divided by this is 54. The 36 it is 540, and this is 2 zeros. So if I take this to the numerator, I'll keep 1 over 54 here and 10 raised to minus 3 there. Then I have to write this in terms of 1. The options are 1.85. In terms of one digit I have to give. I don't have to know the digit, so just I'll just keep a one digit. I'll also multiply 100 and divide by 100. So if I multiply 100, it becomes this, and 10 raised to minus 5. So this obviously, if it is 50, then it is 2. But if it is more than 50, then that will be less than 2. So this factor is definitely going to 1.85. So we are not going to waste our time. And this is 10 raised to minus 5 per degree centigrade. So this alpha, as you can see, even if we have not gone for this actual calculations, we must have got this answer, because our prediction is that this is 1.85 10 raised to minus 5. 1.85 10 raised to minus 5. You can see here, this is also there. So even if you don't calculate that, then also you will get that as the answer. So this is the right answer, and the option number 1 is correct. Okay, so thank you.